The gap between real life and science fiction appears to be getting closer as scientists are working really hard to bring the future of science to us in the present. Specifically, aerospace engineers are trying their best to figure out how to get a jump into the future. We all know that Starship technology is far from complete. So, how are we going to go about this? Has billionaire and tech icon Elon Musk, the CEO of SpaceX, have something up his sleeve? Is NASA planning to surprise us anytime soon? Well, maybe. As we have just learned about Elon's SpaceX and NASA's new warp drive Starship. Want to know more about this? Stay tuned and find out. Please don't forget to subscribe and click on the notification bell to get the latest updates on Elon Musk, SpaceX, and Tesla. Now, the question on everyone's minds: what is a warp drive? A warp drive is basically a drive enabling space warp. Remember those sci-fi movies where the spaceship swooshes and then arrives at a destination thousands of miles away? Yep, that's basically what a warp drive is. It makes starships travel at the speed of light. If you've seen movies like the Star Trek or Guardians of the Galaxy, you've probably seen a spaceship work this magic. The warp drive is a fictitious superluminal spacecraft propulsion. Sci-fi geeks will tell you that the warp drive engine was invented by the eccentric physicist Zefram Cochrane from Star Trek in 2063. In reality, the first time it was proposed was 1957 by John W. Campbell in his novel Island of Space. However, the Star Trek Enterprise would take the credit for making it popular. The warp drive is a fictitious application of the Alcubierre drive, which is a theoretical solution to the central theory of relativity field equation. On paper, it's a highly speculative but possibly valid solution to the Einstein field equation, specifically how space, time, and energy interact. The warp drive was proposed by theoretical physicist Miguel Alcubierre during his PhD study at the University of Wales. He based his theory on the solution of Einstein's field equation in general relativity. Einstein believed that a spacecraft could travel faster than light speed if a considerable energy density field lower than that of a vacuum could be created. So, is a warp drive practicable? Is it applicable? Is it even real? Aside from seeing it work on television, could we imagine ourselves on one? For it to be feasible, a spaceship will have to traverse distance by compressing faces in front of it and expanding space behind it, resulting in an effective faster than light travel. Within regular space-time, it is difficult for objects to accelerate at the speed of light. Instead, the Alcubierre drive alters space around an item to allow it to reach its target faster than light would in normal space without violating any physical rules. Warp drive draws inspiration from theories such as relativity by Albert Einstein. But the problem is that energy and mass are interchangeable according to the theory of relativity. Therefore, it is impossible for physical objects to travel at the speed of light because they are heavier than the mass of photons. Photons cannot move at the speed of light. There is a need to increase the kinetic energy of the object infinitely so it will exceed the light. Please bear in mind, everything we're telling you right now is theoretical. The equation seems to have been solved by annihilating deuterium with an antimatter infusion reaction moderated by dilithium crystals, which produce a large amount of energy, which is enough to warp the space-time and drive the spacecraft to travel faster than light. The notion of space traveling by the speed of light has been criticized as illogical and linked to other theories in science that do not exist in our present world. Theories such as anti-gravity and negative mass. Some people still believe that the warp drive can actually work. William Shatner, a popular science fiction author known for his work on Star Trek, believes that it will take 2.5 million years to go to Andromeda, our nearest large galaxy. Even if humanity were able to build a ship that could travel faster than light, our options for travel will be limited. It's a lot easier now, but it's still bothersome. As you obviously know, the cosmos is enormous. Could we, on the other hand, build a ship that goes faster than light? Harold White, a NASA scientist and leader of the Advanced Propulsion Team, was in charge of the space agency's attempt to see if a faster than light warp drive is viable. He believes that if the exotic matter ring around the spacecraft took the shape of a rounded donut, the amount of energy required would be more along the lines of the mass of the Voyager 1 probe launched back in 1977, and could be made less if the intensity of the space warp bubble were to oscillate. According to an interview cited via space.com, Harold says that experiments are already underway at the Johnson Space Center, but we'll have to wait a while before we can jet set off to distant solar systems. White explains, "We're trying to see if we can generate a very tiny instance of this in a tabletop experiment to try to perturb space-time by 1 part in 10 million. Nonetheless, the fact that we are still trying to figure out if a warp bubble can develop shows how much effort needs to be put into place before we can think of using space travel for that effect. It's definitely going to be a very expensive project, and a lot of great minds are going to have to work together to make this one work. The ramifications for a warp bubble that allow fractional speed light are huge. The capacity to travel at a 1% light speed would make exploration and colonization colonization of Mars or even the moon considerably easier. One piece of good news is that earlier worries suggested a warp drive could wipe out an entire solar system. Data analytics have suggested otherwise. This is very unlikely. Still, any boat in proximity to a warp drive ship is definitely a risk. From Alcubierre's initial assessment, the planetary-sized power source will be required to move current data. This means that we might build a spacecraft with a power source the size of Voyager 2. Could Elon Musk, the founder of SpaceX and Tesla, become real-life Zefram Cochrane, the fictitious Star Trek inventor of the warp drive? Well, the answer is no. SpaceX is not developing a warp drive. SpaceX is trying to go to Mars, which will already require some of the most advanced technology ever developed by humans. They don't need to go faster than light to reach Mars, so right now it would only be a distraction. Some people believe that Musk should expand his dream, as they believe in his capabilities to break boundaries with his tech innovation. One of those people is Neil deGrasse Tyson, an American astrophysicist, planetary scientist, author, and science communicator. In a tweet on December 9, 2019, deGrasse addressed the billionaire tech icon and SpaceX CEO. Dear Elon Musk, when are you going to stop dallying with Mars rocket and hyperloops and electric trucks and brain-computer interfaces and turn your ample resources to developing a warp drive? Sincerely, space geeks of the world. Well, Musk wasn't about to give up on SpaceX and Tesla to pursue a Star Trek fantasy, so he responded persuasively to deGrasse. If we create a city on Mars, Earth-Mars travel will be a powerful forcing function for inventing something like a warp drive. Maybe in the long term, Musk will add a couple more goals, but for now, we know his Mars ambition is the only reality he sees. The Mars colonization project is also a cool ambition. Apart from the cloud tops of Venus, the conditions on the surface of Mars are closer to those on Earth in terms of temperature and sunshine than any other planet or moon. Due to radiation, substantially reduced air pressure, and an atmosphere with barely 0.16% oxygen, the surface is not habitable to humans or most known life forms. If not properly done, the Space Warp Drive project could end up hurting astronauts. It will be a waste of funds and a futile effort for hardworking scientists. Scientists have deduced and compiled a series of side effects that we should watch out for because of space radiation and gravitational difference. People are liable to suffer from weakening bones and muscles, osteoporosis, and cardiovascular issues. We suggest that scientists shouldn't be in a hurry, although it would be pretty to see humanity once again explode our minds with more space innovations. Until next time, don't forget to share your comments and like this video.